All right, so we can learn next about bond polarity. So in covalent bonds, we said electrons are shared. However, even though they're shared, they're not always shared evenly. Sometimes they are, sometimes they're not. My analogy to this is when I was in high school, me and my sister had a car, which means like 90% of the time my sister had a car, right? So anyways, if you take a look at an HF bond, this is what the Lewis structure would look like, one bond for each. They're both one electron short of having a filled valence shell. And so the electrons in this bond are not shared evenly. Most of the time, the electrons are on the fluorine. And so this is shown through what are known as electrostatic potential maps. And so here's kind of an image of that. And so you can see HF here. This blue region means little electron density, so that the electron doesn't spend a lot of time here. And then this red region is a lot of electron density. So the electron spends a lot of time there. So there's different ways we can denote that, two main ways. So again, if we draw HF and we want to say the electron is spending most of its time on the fluorine, what we say is that it then has a partially negative charge. And so the way we show this is this delta sign and then a negative, and then the hydrogen is partial positive, so it gets a delta sign and positive, right? So this is a delta sign, and then this hydrogen gets the partial positive, while fluorine gets the partial negative. Another way to do this is through a dipole arrow. So we have our HF here again, and then we're going to draw an arrow on one end. We're going to have kind of this plus sign towards the positive end. And then the arrow is going to continue out and end to the point. And so it ends at the point at the negative end. So positive arrow on the positive end, and then the arrowhead on the negative end. And this is what's known as a dipole arrow. So both of these are common, and you should be able to draw either one of them. So next up, we'll learn about what makes a bond polar.